Good evening. Today is Tuesday, November the 17th. Today in pre-calculus, we looked at inverse trigonometric functions, inverse sine, inverse cosine, and inverse tangent. These are basically when you say y equals the inverse sine of x, you're saying that the sine of y is x. So if we look at a situation here, I'll show you kind of what we looked at today if we share the screen. So there's two ways if you look, if we say y equals sine minus 1, and I'll put exponent minus 1 x. That's the same thing as saying is equivalent to sine y equals x. Okay, so y is the angle whose sine is x. Now you will see this sometimes y equals arc sine x. These two expressions mean exactly the same thing. It's, some authors prefer to use the y equals arc sine x because in this case here where you have a minus 1 exponent, some students might think that that's the same thing as 1 over sine x, and that is not the case. So it's a little bit less confusing if you use a y equals arc sine x terminology. So, but what you're looking at here, the biggest thing you need to remember is you have a inverse function here. If you go back and remember what we did with inverses before, so I'll go ahead and draw my axis here, see, so you can kind of see. If you look, with the y equals sine x function, the y equals inverse sine x function is a reciprocal. So remember, the sine x function has a point here at, we'll put this in a different color. The sine x has a point here which is 0, 0, right there. And let's see, we'll make this a little wider for this purpose. Okay, so that's 0, 0. And over here it has a point which is pi and 0. So sine of pi is 0. So we have pi and 0. And we have 0 and 0 here, and then we would have 2 pi and 0. And we have our other function. So our function, if we come across here and look at the dotted line across here, remember we always draw this y equals 1 line across here so we can kind of tell y equals 1 and y equals minus 1. So we go bloop, 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 bloop. So we can draw the sine curve here now. It will come up like this. It will come up to 1 at pi over 2. It will come back down to 0 at pi. And it will come back down to minus 1 at 3 pi over 2. And it will come back up to 0 at 2 pi. Now, so remember what happens with inverses. You switch the order of the coordinates. So like this point right here is, this point is pi over 2. And 1. So the point on the inverse would be 1 and pi over 2. So that point's going to be somewhere about right here. So if we draw the inverse with a different color here, so see, we can come up here and put in a point right here, which is about 1 and pi over 2. Okay, that would be 1 in pi over 2. And then we would have a corresponding point. See, 0, 0 is not going to change. It's still going to be 0, 0. But then we would have a point up here somewhere, which is 0 and pi. So this would be 0 and pi. So you can see that your inverse function, inverse sine, would look like this, and it would basically just snake up the y-axis here. It would come down like this over here. It would come out, and it would come back to 0, and it would come back and go like that, just kind of snaking up and down the y-axis. Now, if you'll notice, the original sine function is not a one-to-one function, so the inverse is not a function at all. But what happens here is, for purposes of calculations, the mathematical community has decided that there is a principal range here, and I will do it in a different color here. Let's do it in yellow. So the principal range of the inverse sine function starts here at minus pi over 2, and it comes up here until it gets to pi over 2 right there, right? So if you look, now this part right here, if you go back to the original function, now the part of the sine curve that created this inverse is a one-to-one function, so it now has a inverse, which is also a function. So you can kind of see. So the key thing you got to remember here is the range of the inverse sine function is from minus pi over 2 to pi over 2. Because if you do an inverse operation on your calculator, this is pi over 2 up here, pi over 2. If you do an inverse sine calculation on your calculator, you're always going to get an answer from minus pi over 2 to pi over 2. Even though you might have a situation, for instance, that looks like this. Let me undo that. I'll draw this a little better. Even though you might have a situation that looks like this, where your angle is in the second quadrant up here. So you got an angle here. This would be your angle theta. Starts here and goes around like this. So that would be angle theta. And let's say this is, if you draw this triangle here, this would be minus 4, and this would be 3, and this would be 5. So if you did an inverse sine, the angle whose sine is 3 over 5, which is what the angle here is, see, you would get not an angle that is an obtuse angle, but you would get basically the angle which is right down through here, which is the reference angle that goes with this angle here. And you would get an angle of, I think it's about minus 30 something, 30 plus, whatever, 30 plus. So what you got to remember is anytime you do an inverse sine operation, which is this one right here, you're going to get an answer that's somewhere between minus pi over 2 and pi over 2, or between minus 90 and plus 90, okay? Now, the key thing to also remember when you look at this, your inverse cosine, so if I do y equals, I can make over here, let's do this. Okay, we're going to do this. So we're going to go text, we get in here. So we can do y equals the arc cosine of x. The range here is from 0 0 to 180 are pi. And then finally, the third one here, which we're looking at, is the y equals arctangent x. The range there is similar to the inverse sine, but in this particular case, it's just minus pi over 2 to pi over 2, because remember, the tangent function is not defined at pi over 2 and minus pi over 2. So the biggest thing you need to remember about those, you need to remember these ranges. For the arc sine, it's from minus pi over 2 to pi over 2 closed interval. For the arc cosine, it's 0 to pi. And then for the arc tangent, it's minus pi over 2 to pi over 2. So now, if you look, so I will go ahead now and erase. You can take a second, pause here, and look at this if you need to. Then I'll erase and just kind of show you a couple of problems that we looked at that take advantage of this inverse sine operation. So get rid of all this stuff. Now, most problems you can do with your calculator, but if you have some where it says, okay, find the exact answer. So find exact answer to y equals, say, arc sine of 1/2. Now, if you go back to your 30, 60, 90 triangle, which you have, remember your 30, 60, 90 triangle, you got that there. You got your 30, 60, 90 triangle. It looks something like this. And then you go like this. So this is 60 here. This is 60. And this would be 30 up here. And down here would be your right angle. Remember, you have the short side is half the hypotenuse, so the hypotenuse is 2, short side is 1, and the long side is the square root of 3. So anytime you see exact answer problems, you're going to go either to this triangle or to the 45, 45, 90 triangle. And you notice here, the angle whose sine is 1/2 is 30. So the answer here would be y equals 30. Now, one of the types of problems that you will run into, sometimes you might have something that says, okay, you come down here and you want to find the sine of the arc tangent 4/3, right? 4/3. And you say that's equal to y, okay? Now, so what you have to do here is you have to draw yourself a triangle. So we'll draw our triangle here, such that the tangent is 4/3. So if you'll notice here, when I draw my triangle, I come down like this, and I can come across like this, okay? Now this right here is my angle, we'll call it x. Here, I'll do this with this, okay? So we can do this, this is x. And then the tangent of x is, so this is x right here. The angle whose tangent is 4/3. So now the tangent is opposite over adjacent. So that would mean this right here would be 4. This right here would be 3. And once again, I have my 3, 4, 5 triangle, so I would come over here and this would be 5. Now, so the question asks, okay, what is the sine of the angle whose tangent is 4/3? So x is my angle, and I look at my triangle here and I say, okay, what is the sine of angle x? And the sine is defined to be opposite over hypotenuse. So the answer to this problem here would be 4/5. Now that kind of covers a couple of the types of problems. I'm going to stop sharing here. Once again, if you need to pause this and look at what we did, you can do that. I will stop sharing here. If you look once again at your schedule, we will be working through the rest of the chapter, but the test on chapter 4 will not occur until after Thanksgiving. So when we come back from Thanksgiving, we'll have a day or two of review, and then we'll take that test on chapter 4. So I will pause now. If you have any questions, send me an email, and I will get back to you. Otherwise, I will see you tomorrow afternoon.